We're going to take a look at maximum and minimum applications. There'll be a lot of pausing in this video, like pause and copy it down, just because I'm not going to play a video while you watch me write something down, because there's a lot of writing. So you're going to make a tab, make it 2 pages, because we'll do 4 examples. All right, so label it maximum and minimums. All right, then go ahead and pause this video and copy that down. Pause the video and copy that down. Go ahead and do it again. Pause the video and copy that down. This is a listening check. Put a box around the title. Go ahead and do it one more time. Pause the video, copy that down. Alright, so let's take a look at this, okay, now that we have our notes for it. First step is draw a sketch of the situation, so let's do this. It's a rectangle garden against the barn. So there's my barn. I'm going to do a rectangle garden. It's leaning across the barn. So there's a rectangle garden across the barn. I'm going to label X and Y. Let Y be what looks like the Y axis, like going up and down, and let X be, I guess, the width of the base. Okay. All right. So what are we saying? So when we add all these sides up, it's going to equal 100. Right? When we add the 3 sides that we're doing the barn of the fence, it's going to equal 100. So we do X plus Y equals 100, because when you add 3 sides, that's going to give us 100. And that means simplifies to X plus 2Y equals 100. Okay. Alright, so the question is, what's the maximum area? So we have to find something to do with the area. Alright, so I'm going to write the area of any rectangle is base times height, right? So what's the base? X. And what's the height? Y. So the area of this rectangle will be XY. Alright, then in order for me to take the derivative, I need it in terms of one variable, okay, because I need to set it to equal to 0 to find the maximum or minimum, but I need one variable. So that means I'm going to take my first equation and solve it for one variable. Let's solve for X. It doesn't really matter what you solve for. So I'm going to solve for X, take 2y to the other side, it's going to be X equals 100 minus 2y. Alright, so now that we have that, the area, remember, is X times Y, okay, and X is 100 minus 2y. Go ahead and get in the house. That's going to be 100y minus 2y squared. Alright, now we're going to take the derivative of that and put it equal to 0 to find our maximum and minimum, right? So the derivative of a with respect to what letter? Y. The derivative of a with respect to y is going to be 100 minus 4y. And that needs to be equal to 0 in order for us to find our critical point. So we're going to get, taking negative 4y to the other side, we're going to get 4y equals 100. Divide both sides by 4, you're going to get y is 25. Now if y is 25, plug it back in to the original equation and see what x is equal to. So y is 25, then x has to be equal to 50, because 2 times y is 50, so 100 minus 50 is 50. Right, now check if it's a maximum or minimum by taking the second derivative. Okay, the second derivative of that original function is negative 4. Doesn't matter what you plug in, it's always going to be negative 4, which means that's negative. Concave down, which means that's a maximum. So that makes sense. That's the maximum area. Pause the video and copy this down. Alright, so this is a box with a square base. The first thing we're going to do is draw what it is. So it's a square base with no top. So go ahead and draw a box with a square base with no top. I mean, as accurate as you can, doesn't matter. It's a sketch. The listening check, color in example 2. Color in example 2. Alright, so it's an open top, so there's nothing on the top. You need to remember that. The material is going to, well, the volume of this, because it says cubic, that means volume, is 108 feet cubed. And it's asking what will be the minimum, or what dimensions will cost the least note of this material. So the material has to go around all the sides and the base, right? So we're going to label x, x, y. Alright, area of the base is x squared, because x times x is x squared. Area of the 4 sides, remember the 4 sides all the way around, not the top, is x times y, and then there are 4 of them, so 4xy. So that means the total area around the whole thing and on the bottom, not top, is, let's say, the total material we're going to use. It's going to be adding those things together. So x squared, the area of the base, plus the 4 sides, 4xy. So that's the material we're going to use. Alright, what other information are we given? We're given the volume. What's the volume of a cube? The volume of a cube is base times height times width. So what's that? That's the base, which is x, times the height, which is y, times the width, which is x. That's going to be x squared, y equals 108. Solving for one of the variables, so we can plug it back in. Let's solve for y, and I don't want to take the square root. So divide both sides by x squared, that's what you're going to get. Now you're going to plug that back into the total area of the material. So you're going to plug in where you see y, plug in that whole thing. This is a listening check. Circle V equals 108 feet. Circle V equals 108 We're going to get M equals x squared plus 4x times 108 over x squared. What's going to happen to those x's? They're going to cross out. So 1x on the top is going to cross out with 1x on the bottom. It's going to leave x squared plus 4 times 108. It's going to give me 432 over x. So taking the derivative of this, we can put it equal to 0 with respect to x. It's going to be 2x minus 432 over x squared. And now we're going to set that equal to 0 in order to find the critical points for the maximum or minimum. So what does that mean? I'm going to multiply everything by x squared. So I'll get 2x cubed minus 432 because the x squared on top cancels with the bottom. And then we're going to get, taking 432 to the other side, dividing both sides by 2, we're going to get x cubed equals 216. And then what number multiplied by itself 3 times is going to give me 216. This is a listening check. Color all this work I'm doing on the side. Color all this work I'm doing on the side. Alright, it looks like it's 6. So it's 6. What are the units actually? What are the units we're looking at? Feet. Alright, so x is going to be 6 feet. Alright, when x is 6 feet, what's y? So find the equation that you had x and y in it. And that's going to be that one right there. So y equals 108 over 6 squared, which is 36. So 108 over 36. Alright, I have no calculator, so I'm just going to divide by 2 until I simplify it. So I get 54 over 36. Divide that by 2. 27 over 9, which divides into 3 feet. So when x is 6 feet, y is 3 feet. I want to check to make sure that this is indeed a minimum. And how do I check my critical points? I plug it into the second derivative. So go ahead and take the second derivative. So the second derivative is going to be, where is my first derivative? Okay, right there. It's going to be 2 minus, oh, but when you take it to the top, that's going to be negative. Negative is positive. And then 2 times 432 is 864 over x cubed. And now you're going to plug in x is 6. So when you plug in 6, I really don't care what it actually comes up to. It's just that it's all positive, right? So I don't care what number it is. So positive means concave up, which means it's a minimum. So I'm just making sure that it was indeed the minimum amount of material. Pause the video, copy that down. I want to pick up in part 2 at this very point. Let's practice.